yeah, I spent 3 weeks doing field work up in Crested, Butte. This was my field site, so horrible, horrible place, as you can see. No. But I looked at identifying variations in hydraulic conductivity at this site, not specifically to learn about that site, but to more improve methods of slug testing across the whole world. So once again, my site is in Crested Butte, which is just southwest of Denver. And I conducted all my research on the East River at a certain meander. And the meander is just a winding section of the river. So at Meander C, there were 6 wells. Sort of popping out. There were 6 small wells situated around that meander, which is where I conducted all of my experiments. So before we get into any more into slug tests, I want to go over what hydraulic conductivity is. So hydraulic conductivity is how easily water flows through a material. So an example of a material with a high hydraulic conductivity will be sand or gravel, because you know that water flows through it very easily. Something with a low hydraulic conductivity would be clay. So you know from experience, if you have puddles on top of clay, that it takes a very long time for that water to travel through. So we care about hydraulic conductivity for many reasons, one of which is any sort of chemical spill or toxic material that gets into groundwater. We can use hydraulic conductivity to calculate the velocity and direction of groundwater flow. So if there's something bad that gets into the groundwater, we want to know where it's going and how long it will take to end up in that location. This is an example, a very recent example of when we would use that sort of calculation. So last month in Oregon, there was a train carrying 65 cars of crude oil near a wetland right here. It derailed, and some of the cars caught on fire, and a lot of them leaked oil into the ground. So hydrologists were able to calculate the hydraulic conductivity of that area, and then go on to calculate the velocity of the groundwater in that area and determine that the contaminated water was moving towards this wetland. So they were able to put in little oil sheens on top of the water, oil sheen catchments on top of the water to prevent the oil from causing any more additional damage. We also care about hydraulic conductivity whenever we're talking about groundwater pumping. As I said, hydraulic conductivity is how easily water flows through a material. So if you have an aquifer with a very high hydraulic conductivity, if you pump out a lot of water, you're not going to have to wait as long as you would with an aquifer if the aquifer had a very low hydraulic conductivity. Aquifer with a very low hydraulic conductivity, if you pump out too much water, the well will go dry. So we measure hydraulic conductivity by conducting slug tests. So to start out, we used these wells, which are very, very, they're not like wishing wells, so don't think that they're these massive things in the ground. They're just pieces of PVC pipe about 1 to 2 meters long. There's a well screen, which is just sections of the bottom section of the PVC pipe, which has small holes or slits in it that allows water to pass through pass through the PVC into the well, and so the water level inside of the well will be the same as the water table outside of the well. There's also a small device called a pressure transducer at the bottom of the well, and that just records water level changes. So in order to conduct slug tests, all you have to do is displace the water inside the well and record the amount of time that it takes for the water to recover. And then you use this equation to get hydraulic conductivity from that. So K is hydraulic conductivity, which we measure in meters per year. Everything in green is just well dimensions, so the radius of the well. In our case, it was about 5 centimeters. L is the length of the well screen. Most of the wells we had were 76 centimeters, around 76 centimeters. T37 is what we get from the actual slug test. T37 is the time the water level takes to fall to 37% of the initial change. So there are 2 main types of slug tests that people do. The first one is water slug test. So you take the initial water level of the well, you displace that water by adding additional water, and you record the amount of time that it takes for the water level inside the well to recover to its normal level. So water slug tests are good if you're in a spot like where I was, where I'm right next to a river, there's an abundant water source. I don't have to walk very far to conduct multiple slug tests. But there's also metal slug tests. So it's the same basic principle. You're only displacing water with a metal slug, which is a small metal cylinder, and once again recording the time it takes for the water to recover. This is good because they're smaller in volume. The metal slug that we used was about 35 milliliters. So it takes a smaller amount of time for the water level to recover since you're displacing less water. It's also good if you're in an area that doesn't have a whole lot of abundant water sources around. So you don't have to walk super far to get that water to slug the well with. You can just dip that metal slug in there. So some pros of slug tests, they're inexpensive. Aside from the pressure transducer at the bottom of the well, all the other equipment is relatively cheap, especially if you're doing water slug tests, because you can just go to a river or pond or lake and pour water into that well. There's a low environmental impact. There's no harsh chemicals used. There's no super long-lasting harmful effects on the area around the well. And they're very simple to conduct. As I said before, you're just displacing the water inside the well. No fancy equipment needed. There are some cons, however. Environmental factors such as evapotranspiration, which is water leaving the ground and lowering the water table. The water is being taken up by plants and it's being evaporated into the atmosphere. So that happens at the hottest parts of the day, whenever the plants need the most water. There's also potential for variation, which is what this study looked at. So we compared two factors. The first one is user variability, which is very important to know how much variability you're introducing into your study if you're having multiple people conduct slug tests. So typically during doing field work, there's not just one person doing field work. There's a whole team of people with different ranges of experience levels. So you want to know how much variation and variability you're introducing into your data by having those different people conduct those slug tests. And we also looked at test type variability, and test type variability is just the difference between hydraulic conductivities that you get with the metal slugs versus the water slugs. So we looked at the user variability, and it's sort of blocked up there, but we used the Crested test, which is an analysis of variance, or an ANOVA, that analyzes the variance and medians between several different groups. So rather than going farther into that and describing more about how that test works, I'm just showing you the medians. You can see that the medians are pretty similar, only 10 meters per year apart, which for a value of hydraulic conductivity is pretty good. So this shows us that the data that we collected from each user is statistically similar. We see the opposite with the metal slugs versus water slugs. You can see that the water slug has a median over double what the metal slug is. We analyzed this with the same test, the Crested test, and found that they were statistically dissimilar. But before we came to that final conclusion that it was the metal slugs versus the water slugs that was causing that variation, we wanted to make sure that evapotranspiration wasn't having any effect on that data. So since the metal slugs are a lot smaller than the water slugs, we thought they might be more susceptible to water table changes. So what we did was we took the 4 earliest slug test times, so the earliest in the morning when evapotranspiration had the least effect, and we compared those. So we had 4 metal slug tests compared to the earliest 4 water slug tests. However, if you look at the medians, you can still see that the medians are exactly the same, and the 2 data sets are still statistically dissimilar. So in conclusion, multiple people, like a whole team of people, can conduct slug tests without sacrificing data quality. You don't have to worry about messing up any of your data by having a bunch of different people conducting slug tests, and it will save you time, so that's good. But only one type of slug test should be used for doing those slug tests. You shouldn't have one person doing metal slug tests in one section and one person doing water slug tests in a different section, because that will introduce additional variation into your data, and nobody wants additional variation into your data when you can help it. Okay, I'd like to thank all my mentors, Helen, Kamini, and Holly, as well as everybody at RESESS Team NABCO. And I would like to thank NSF for funding this project. It was a really fun summer. And any questions?
Question. Thanks for a great presentation. I had a question about, in the original equation you showed, you talked about T37. What's the reason for choosing that level?
I'm not entirely. It was developed by Horselove. I'm not entirely sure the method behind choosing that exact number.
I imagine it has something to do with how long it takes for the water to recover.
Yeah.
I mean, obviously, in theory, you would never get back completely to the original level.
You can. I'm pretty sure you can. Yeah, I'm not entirely sure where that where the actual number of 37% comes from, but it works for calculating it. Yeah.
Sure.
Other questions? Oh, Shelley. Very nice presentation. My first work with an environmental company was doing a series of slug tests.
Yeah.
So I had a question about the water method versus the metal slug method. And when you look at the research that's done, which methodology is more common?
I'm not entirely sure, because a lot of, like you said, you were an environmental, like you were working. Was it for a company or like?
It was for a company.
Yeah. So like.
Yeah, per test.
Yeah. Some of that like isn't super well known, or at least to me, I don't really have like the best access to like who uses what like method the most often. I'm not entirely sure what is the most common. I just know that they're both used often. I'm not sure which one.
Yeah, I was thinking that if more people use the metal slug test in areas that don't have a lot of water, and bringing in 20 gallons of water is a challenge, that you might have a whole region that has a K value that's different than areas where you would probably use the water slug test, because it's easy to get the water.
Yeah, and that's one of the problems, because we don't know which one is like right. So yeah, I'm not. Sorry, I'm not entirely sure. Yeah, further research for sure.
Yeah. Thank you.
Okay, I think Scott has a question.
So are there different errors between the water slug test and metal slug test? Because I would assume once the metal slug test is finished, you pull the metal slug out, and then you have to wait for it to.
Yeah. Yeah. And I wouldn't call it error because we don't know like which measure is the most accurate one, but it is variation. But yeah, it's great though, because you can use pulling the slug test out and sort of switch up, like we use MATLAB to go through all the data recorded by the pressure transducer. So once you dump the slug test, the metal slug in, and you take it back out, you can sort of do like a reverse slug test. So you can do sort of
two
slug tests.
Measurements for one test.
Yeah. So yeah, you do have to wait longer for it, but you also get to do 2 slug tests in that time. Yeah.
Great. Thanks, Cass.